video we will be studying atomic structure. I personally think this is the easiest topic out of all of the topics for chemistry A level, because all it is just memorizing the questions in the exam regarding like maths questions. They'll all be the same questions that they ask you, however the numbers will be different. So in this video we'll go over all the content, and if there's time we'll go over some exam question walkthroughs, or that will be the next video. But this topic is very easy because most of it is just GCSE, apart from mass spectrometry, but that's all just revision as well. Right guys, so this is GCSE, but they will ask you in the exam whether it's to complete the table or to just give answers, whether it's adding or subtracting isotopes. So relative mass of a proton is 1. Relative mass of the neutron is also going to be 1, and the electron, this one in GCSE you would say it was near 0 or 0, but in the A-level exam you're going to say it's 1 over 1840. The examiners, especially in Oxford AQA, they love to see you write 1 over 1840, and they will ask you this question. Relative charge, obviously this is +1. Neutron is always going to be minus because it's neutral. And the electron's always going to be opposite of the proton, so it will be -1. For any atom, let's say sodium has a symbol Na. It's a neutral atom, so it must have the same amount of protons and electrons to give an overall charge of 0, because the amount of this will cancel out the amount of that. So let's say sodium has a atomic number of 11, so it has 11 protons. Sorry, the iPad just moved. And it therefore must have 11 electrons. So in total we have a plus charge of +11. Here we have a negative charge of -11, and that the sum of +11 minus 11 is 0. So the overall charge is 0. But let's say you have a sodium ion. So sodium is in the group 1 of the periodic table. That means it will form +1 ions. That means that it will lose an electron because it will be positive by 1. So the atomic number never changes. So in sodium it's 11. So the proton number would be 11. So then that means that it will have a plus charge of +11 in total. And now if we want to have a +1 charge overall, we know that the electron number is going to have to decrease by 1. So instead of 11, it's going to be 11 minus 1, which is equal to 10. And therefore, it will have a negative charge of -10. So the sum of these two would be +1. So we would write this positive ion as Na+. We can also do this with an anion, so a negative ion. Let's use chlorine as an example. So a chlorine atom would have a proton number of 17. And we say this is a atom, so it has 0 charge. So if it has the proton number of 17, it will have a positive charge of +17. And now if we need a 0 charge, how many electrons do we need? 17 electrons as well, which will therefore have a charge of -17. The sum of this is 0, so it has 0 charge. However, if we want to have a negative ion of Cl, which we would say it's Cl- because it is in group 7, so it will form -1 ions. So ions with a charge of -1, we call these anions. Anything with any ion with a negative charge is an anion, and any ion with a positive charge is called a cation. The way I remember this is a cat is cute and cuddly, it's a positive thing, so we'd say it's a positive ion. Anion sounds like onion, gives you bad breath, so that's a negative thing, so it'd be a negative ion. Anyways, we know that this ion would be a -1 charge. So, as I said before, proton number, atomic number never changes, so it would have +17. But to get an overall charge of -1, we'd have to have an electron added to the electron number previously existing. So we'd have -18. So we'd have 18 electrons. So the atom has gained an electron to become a negative ion. So the total +17 -18, that would be -1, which would give you a minus charge. We could do this with group 2, group 3, group 4, group 5, group 6, group 7. However, obviously I think this is GCSE, so you guys know this. The one thing I will say is no matter what ion you have, let's say you have a magnesium ion, you will always put the number first in the charge. So magnesium forms +2 ions, but you'd always put the number before the plus or the minus sign. Let's say potassium forms a +1 charge, so you'd have K+. You'd have aluminium forms a +3 charge, so you'd put Al3+. And the list goes on. Next thing I will mention is, next thing we'll be going over is mass number. I'm going to go skim through this because I really think this is an easy bit. This is basically literally just GCSE. So mass number, you're going to have to memorize this definition because they will ask you this in the exam. It's a total number of protons and neutrons in the nucleus of an atom. For example, carbon has mass number of 12. So it also has an atomic number of 6. That means it has 6 protons. From here we can find the neutron number, which is 12 minus 6, which is 6. So it has 6 protons and 6 neutrons. So isotopes, you're going to have to memorize this definition as well. They will ask you this in the exam. An isotope is an atom of the same element, so it has the same atomic number, same number of protons, with different number of neutrons in the nucleus. So what that means is, for example, we said carbon before. Carbon has 6 neutrons. Carbon-12 has 6 neutrons and 6 protons. We have an isotope called carbon-13. Carbon-13 will have 6 protons as well, but it will have 7 neutrons because 6 plus 7 is equal to 13, which is the mass number. The chemical properties of isotopes will all be the same. So carbon-13, carbon-12 will be the same, will have the same chemical properties, but the physical properties will be different because the density of the material will be larger if the mass number is larger. For example, in mass spectrometry, we'll learn that a heavier atom travels more slowly than a heavier ion, travels slower than a lighter ion because of mass numbers different. From here we can learn mass spectrometry. Okay, so a mass spectrometer is used to determine all the isotopes present in the sample of an element to identify the elements the isotopes present in that sample. So there are 4 stages in mass spectrometry. There's ionization, acceleration, separation, and detection. So here we have a sample. The sample will go into the ionization area, as this is the mass spectrometer is split into 4 different sections. So we have the ionization area, acceleration area where ion drift will occur, we have flight path, and we have the detector. So, ionization. Sample is ionized, forming positive charged ions. It will form a +1 ion. So, ionization. There are 2 different ways to ionize a sample. There is electron impact. This is used for elements with low MR compounds, like let's say potassium, like just a K, or magnesium Mg. No large molecules, for example, you wouldn't have like CH3COOCH because that is too large and that could fragment the molecule while ionizing. So how this works is there is a heated wire which we call an electron gun. So this is your electron gun here. This, as it's heated, will shoot out negative electrons to a positively charged plate, as it is negative and negative is attracted to positive. The sample is vaporized, so it's turned into gas. The sample travels through. This is your sample dash lines, and as it's passing through the high energy electrons, the high energy electrons will bombard the vaporized sample, and this will cause the an electron from each molecular atom to be knocked off. This will cause a positive ion, a positive charge for every molecule or atom, so they will turn into positive ions. After this, there is a negative electric plate here. Now that they have a positive charge of +1, they will be attracted to the negative plate, and this is where acceleration occurs. Now, there's a second form of ionization, and this is called electrospray. This is for large MR compounds like alcohols, ethanoates, but you don't have to learn about this in P1 of IA level. But this is used for like proteins, just so they don't fragment and they don't break. So the sample is dissolved. You need to write in the exam, when they ask you about electrospray, you need to write the sample is dissolved in a volatile solvent. So what this means is, say you have sugar, you dissolve it in water. You have a sample, you dissolve it in the solvent. There is a needle attached, which is this needle. This needle is attached to a positive terminal of a power supply. Let's say your positive terminal is here. This will give protons. This will send protons to the needle. So as the dissolved sample is passing through this hypodermic needle, you need to write hypodermic in the exam as well. I don't know why, but just it's the hypodermic needle. It will gain a proton. A proton is a positive charge, so it will gain a positive charge. It will then be sprayed outside of the needle, and likewise with electron impact, it will be accelerated to a negative plate. Now, so what I've seen so far in the past international A-level exams, and I have seen the UK A-level, the normal A-level exams, every time they ask about electron impact, they will always ask you to write an equation for this. So what the examiners want to see, say you have an atom called X. We want the X to be in a gaseous state, like I said before. So we're going to write X. It's bombarded with an electron, so we're going to put an electron here. And this is bombarded with this, so this will turn into a positive charge. You need to have state symbols. It will always be gaseous. And now that an electron has been knocked off, we are going to have 2 electrons, because that plus 1 more is 2. Examiners always want to see this equation. This equation needs to be right every time. But if you're lazy, like some people, you can write it like this. You actually don't need that. You can literally just put... To be fair, I personally don't like this one, because you could easily get confused with like another type of reaction occurring, like half equations, and we're not doing half equations here, we're doing the electron impact equation. So for electrospray, it's a little bit different because, like I said, we're not losing an electron, we're gaining a proton from the positive terminal to the needle. So say we have the same thing, we have X, which is in a gaseous state. It's dissolved in a volatile liquid, so the atom will always be in the gaseous state. So, like I said, it gains a proton. While we're writing reactions, we can always write a proton as a H plus ion. And this is because a H plus ion is literally just a proton, because if you think of a hydrogen atom, it's made of one proton, one electron. We remove an electron, it becomes plus one ion. So we just write it as H plus. So H plus, that's in a gaseous state too. Draw your arrows. Examiners will always want to see that. There's only one right way to write that, so you're gonna have to memorize that. This is where your whiteboard comes in, where you can just keep writing and rubbing it out, writing and rubbing it out. Or if you want to be extra and add some flashcards, I personally don't think that's necessary, but if you want to, you do you, I guess. Next thing we're gonna do is acceleration, right? Acceleration, let's see. Also, apologies guys if I'm speaking really slowly. This is my first video. I will get better soon and help you be more helpful in your exams very soon with more videos. If you guys like, subscribe, maybe, interact, then the videos will be better. Alright, so we have acceleration. Acceleration is literally the easiest thing to understand. You have a positive ion, it's going to be attracted to a negative plate, because we know this since birth probably, opposites attract, like with magnets. Positive ion will be attracted to a negative electric plate. You will always need to write electric. You also need to write electric field. Electric plate or electric field is the same thing. So, say we have two protons, three. No, not protons, ions. Oh, my thing is on charge. Now it is. So, say we have three different ions in the sample. Each receive the same kinetic energy because the attraction is the same. You need to write same kinetic energy because the examiner doesn't want you to see that to gain that extra mark. A mark is the difference between an A star and an A. So, regardless of their mass, they gain the same kinetic energy. Now we know this equation, kinetic energy equals 0.5 mv squared. You learned that in physics too, but that's just a GCSE equation. They will always give you this in the exam, whether it's rearranged to look like this or rearranged to look like that. So this will always be a constant. As the mass increases, this will have to decrease. They are inversely proportional to each other. Now let's say that the mass is decreased compared to the other one, the velocity will be faster. So this ion will travel at a faster rate than this ion because this ion's heavier. Like if you have an obese person and a skinny person running in a race, who would win? The skinny person, because they have less mass on their body. So we know this equation. V is the velocity of the particle, EK is the kinetic energy of the particle, and M is the mass of the particle. Now, in the exam, they will always ask you one question. They will ask you, it will always be a 6-mark question, but the structure of the question is always going to be the same. They're always going to ask you, what's the length of the flight tube, what's the length of the mass spectrometer, or what time does it get into? So you need to know another equation. This is T equals D over V. So this is the length of the tube. This is the velocity of the particle, V. This V and this V is the same. They're the same thing. Here, if you want to just cheat, basically, I personally don't use this equation. You can use this equation for the exam to help you, but I just like to use the other one. I think it's easier. So yeah, they're going to give you, let's write it here. they're going to give you an ion, let's say 65x ion. It has a kinetic energy of, let's say 3. Obviously it's going to be like 3 times 10 to the minus whatever. They're going to give you a time it travels for, so t is like 0.5 seconds. They're going to give you a that's all they're going to give you, really. This, you're going to figure out what the mass is in kg. So to figure this out, if the mass number of the ion is 65, we're going to use Avogadro's constant. So let me get this on a whiteboard better. Right, so this is all they're going to give you in the exam. They're going to say the ion has the mass number of 65. They're going to say the kinetic energy is 3. They're going to say the time, I'm putting here 0.5 seconds. They're going to give you Avogadro's constant, which is that number is too big for me to say. And they're always going to give you the equation. Now don't mind these 3 numbers that I've put in. I've literally just made them on the spot. But I'm doing this to show you that how easy it is. So let's say they ask you what is the length of the flight tube. Like I showed you guys before, in that big chamber that looks something like that, we had the ion drift. We're going to find out the length of this. So we have a 65 ion. What we're going to do to figure out what the mass is, we're going to do 65 divided by, it's always going to be the mass number divided by Avogadro's constant. So 6.022 times 10 Julie 23. Let's put this in my calculator. Right, so it's giving me an answer of 1.079 ... times 10 to the minus 22 grams. This will convert it into grams. Now, I personally like to keep this in the calculator instead of writing it all down. But if you write 1.079 with ... the examiner will give you that mark for at least working out. Now, like I said, this is in grams, but we know this equation from physics GCSE. Mass must always be in the SI unit of kg. So to convert grams to kg, we're going to times it by 10 to the minus 3. Now, you could always say, like, divided by 1,000, you know, but I always put it in my calculator as times 10 to the minus 3. Just so there's consistency and you don't get confused. So I've got 1.079 ... times 10 to the minus 25 kg. Exam tip, like I've seen so many of these questions, whenever you're figuring out the mass, when you've done this step, if you get grams to the minus 22, that's right. And if you convert it to get to the minus 25, you're along the right track. Like, you always need to look for these patterns. If it's minus in the 20s and then minus in the 20s but a larger power when it's kg, that means you're along the right track. Right, so we have got your mass here. We can rearrange this equals 0.5 mv squared into finding the velocity. So we can do v is the root of energy times 0.5 of the mass, or we could do e to e m. I personally prefer this one, but you can use this equation too. I'm just going to use this equation for the sake of the video. So v equals, what was the energy? Energy I've put as 3 joules. So let's do 3 joules. So 0.5 times 1.079 ... times 10 to the minus 25. Plop that in your calculator. Let's do, so 3 over 0.5 times answer. I always keep the answer previously, like this answer, in my calculator so that you never get like a rounding error. So I've gotten v to be 7.4557 ... times 10 to the 12 meters per second. in the exam, obviously I know in GCSE you'd always write meters per second as that, but in A level you always need to write it in ms minus 1. Sorry, iPad went a bit funky. So now we're going to use the equation. Like I said, d equals vt. We're trying to find out the length, so we're trying to find out d. We have t, which is 0.5 seconds, so d equals 7.457 times 10 to the 12 times by 0.5 equals, plop that in your calculator, we've got 3.73 times 10 to the 12 meters. Obviously that does not look accurate, that's because I've chosen random numbers. The answer will always be like what I've seen, it will always like 1.5 meters, 2 meters, 3 meters. It will always be like something less than 5. Significant figures, so here they've given it to 4 significant figures. Here they've given it to 2. I want you guys to always do it to the amount of significant figures, the least number of significant figures. So it's given me 2 significant figures, so just put it to 2 significant figures, so that will be 3.7 times 10 to the 12 meters. Instead of writing 37000, you always have to write it 10 to the 12. And that's the acceleration. So now they're in ion drift, so they're drifting. Like I said before, each ion, like positive ion molecule, with a smaller mass to charge ratio, obviously the charge would be the same, so with a smaller mass it will travel faster than an ion with a larger mass. Like I said, obese person will travel slower than a skinny person. Like I said, heavier particles will take longer to move through the drift area. Ions are distinguished by different flight times, so like we did in that practice question, length that the displacement or the distance that the ion travels per ion is the same for everyone, but the time will be different. This is where detection comes into place. So obviously separation, they've separated because, let's go back to the thing, these ions are traveling faster because they're smaller. These will be traveling slower than that because they're heavier. So detection, when ions reach the ion detector, you need to memorize this statement. This statement is like a hallmark in itself. They will accept an electron and generate an electric current. So when they hit, so let's say positive ions there, negative electric plate, when they hit this negative electric plate, they will gain an electron because negative electric field is just electrons. They will gain an electron. This movement of charge will generate an electric current. This computer then interprets the electric current to produce a mass spectrum. The larger the current means the larger abundance of the isotope in the sample. So if a small current is produced, so that means there is a small percentage abundance of the isotope in that sample. So that's literally, this is a short time of flight called small mass over charge, long time of flight, large mass over charge. We've done this. Okay guys, hope you enjoyed the video. Any questions, leave in the comments, they will be answered, and follow or subscribe for more revision tips and videos on chemistry A-level, physics A-level and maths A-level. Thanks guys, bye.